Hi everyone, hope you are having a wonderful day. It's Tony here. I'm at the Bio Creation Conference here in Lagoon Beach in Cape Town. And here I have one of the participants from the conference. So tell us about yourself, sir.
Okay, well done everyone. I am Stephen Adeyemo by name from Nigeria. I work at Phoenix Biology Institute back in Nigeria. I'm also affiliated to Thomas University. I'm currently having my postgraduate studies in molecular biology and genomics. Thank you.
Okay, Stephen. So tell us a little about the work that you do. What type of pathogen you work on? Do you mostly work on like the wet lab side, or do you want to do some analysis using bioinformatic tools?
Okay, thank you. So I'm a researcher that actually plays in West Lab and bioinformatics. So coming from the background of microbiology, I've always working in the laboratory. So after I got exposed to bioinformatics, I had to find the nexus between West Lab and the lab. So my research spans across oncoviruses, cancer research, and infectious disease, where I focus on designing and developing vaccine and pharmacotherapy for several organisms in order to contribute and make positive global impact. Thank you.
Okay, so is that mostly like viruses, bacteria, communicable disease, and then secondly, do you deal with like a lot of healthcare workers, hospitals? How do you get your samples?
So speaking from the West Lab aspect of it, so we probably get samples, full samples. So finding a way to isolate organisms from full samples.
Okay.
And after doing that, probably when we have funding, we can always proceed to sequencing
Right.
the DNA of such organism. So it's like I said earlier, it spans across bacteria, fungi, and cancer research as well.
Okay.
Because the goal now is not to find a particular niche, a particular organism.
Very wide.
Very wide, but
Okay.
the idea is on pharmacotherapy design, on vaccine design and development.
Okay.
When we are able to study the organism of interest well, then we can coming from the aspect of molecular biology, so they can always find molecular biology techniques that can actually be used to combat the organism of target. So that's the idea. So pharmacotherapy design and vaccine design and development.
Okay, and then in your sort of vaccine design or hunt, do you use artificial intelligence? Do you have a supporting structure where you have computational tools to actually predict?
Yes, exactly. So when it comes to vaccine designing, so we have three major phases: the pre-construction phase, the construction phase, and the post-construction phase. So while running across the pre-construction phase, how we get to study the organism in depth and understand the mode of reaction, the mechanism of reaction of the organism. And after doing that, we most times retrieve and curate data sets, databases like NCBI, Uniprot, DDBJ, and several other databases. And from there, we get to analyze using AI and other bioinformatics tools and a few terminal. And after the analysis, we can always construct the vaccine candidates. And after the construction phase, then we move to post-construction phase where we also get to do some validation, some refinements of the construct and validation, and that will provide an efficient and immunogenic vaccine candidate. So from there, we could always enter the West Lab for further validation of safety and efficacy of the vaccine. So that's what we do majorly.
So you actually compare your sample against existing databases to isolate, the potential functional group of genes that might be a good attachment for the vaccine.
Exactly.
And then, using computational data, you would say perhaps this vaccine would work against existing
vaccine.
All right. And then you obviously mentioned that you come from a molecular, sort of more biology background. Now you're almost, transitioning into a computational environment where you have to run pipelines in Nextflow. You have to compare your sample against existing database. I assume there's a lot of coding. There's a lot of software side that it's not really what you're used to or what you study. how do you sort of find that transition, and what are some of your biggest sort of challenges?
Okay, thank you for that question. So I mentioned earlier that I'm affiliated to Unix Biology Institute, and I'm also affiliated to Redeemers University in Nigeria. So before joining Redeemer University, that's where I'm currently having my postgraduate studies. I worked at Unix Biology Institute, and I'm still currently with Unix Biology Institute. So that's where I was able to learn bioinformatics in depth. So while learning bioinformatics at Unix, I realized that there are some analysis that we do that stem from the background of molecular biology. So I realized I needed more molecular biology experience. So this is why I opted for molecular biology and genomics as for my master's study. So I'm currently rounding up my master's in molecular biology and genomics, and I've been able to learn some techniques that could also be used to comprehend the bioinformatics experience I've had. So
Okay.
I already had like initial bioinformatics experience at
Yes.
Unix Biology Institute where I work before starting my master's at
Yeah.
Redeemer University. And currently I'm also looking forward for I'm not looking forward to postgraduate PhD opportunities in bioinformatics,
Okay.
where I now get to learn the in-depth decoding and several
Like
other
advanced.
exactly advanced
Yeah.
bioinformatics, so not limiting myself to what I've known before. So this is how I am actually transitioning, and how I've been trying to move in and leveraging on what I've known to ensure that I have a proper career path. Thank you.
Yeah, I think that's a really good point that you've said, trying to build yourself and upgrade your skill set so it's more relevant and accessible. So I think from my perspective, we work with a lot of other institutions like, the Africa CDC, FADE, which is a global network, and now we've heard from ABI, which is also Africa Bioinformatics Institute. I mean, from your perspective, you in the lab, you work with your colleagues, people. If you had to request something from like the Africa CDC, is it more training that you need? Is it more conferences like this to have network opportunities? Is it some kind of online structure where you can download training materials or resources that really help you, but also other young scientists to develop their skill sets?
Okay. So from that, I think I will come from the aspect of the students, probably my colleagues, the younger generations. I will kind of focus on that. I want to believe currently, well, probably there could be more improvement, but currently I believe there are enough trainings, there are enough resources, enough materials that could actually help younger generation actually coming on to learn by informatics. So I just want to encourage people to keep trying. At times when you apply, for
You
a
get
training, let's say,
rejected and
then you get rejected, then you tend to feel so down about it, then you don't try again. So I just want to encourage people to keep trying. There are enough trainings for now, based on basic introduction to bioinformatics. There are enough training for now, so people can always apply. So when when you try and you fail, you have to kind of get back up. You keep trying again until you win. So that's the idea. So that's more like to the younger generation. Let them keep trying. There are enough trainings for now,
have
and
to
I
keep.
believe we are also trying. We're also trying to do our best in Africa to ensure that we keep improving, and there
Yeah.
will be enough resources for people to actually gain and benefit from. So that's what I think.
Yeah, get up when you get knocked down and try to stay optimistic to apply those opportunities. So we come to the end of our interview. I think we must just acknowledge the work that you're doing, and we're thankful for your insight that you're sharing with us. On our last note, if I were to sort of ask you to give some personal advice or challenges that you have overcome, or some words of wisdom to the younger generation. People probably in high school, university, and they want to pursue a career in science. Maybe they want to go into computational biology. What would you tell them?
Okay. So I will talk about soft skills. So the younger generation should ensure that they have enough soft skills that is actually needed to I think soft skills is the important aspect of it. So when you have soft skills like adaptability, resilience, problem solving, teamwork, all those things coupled together would actually, help one in transitioning.
Better
So
your chances. So.
exactly, so you get better chances of everything you do. So it's not even about what you do or where you do it. It's about what you have, the potential in you. So you can always, I believe you can always work anywhere. So when
Oh,
it
okay.
comes to transitioning,
Yeah.
so how do you want to transition? But when you have the essential soft skills, it would be easier to transition and
Sure.
find the balance. So soft skills, including adaptability, resilience, problem solving, communication, all those things are coupled
Communication.
together are very, very essential. And like I stated earlier, when you have a resilience, when you have adaptability, you keep trying. No
Yeah.
matter how you feel, you keep coming back up, you keep trying until you ensure that you win. So that is more of my advice to the younger generation. They should keep trying and they should ensure that they gain several soft skills to that will help them stand firm as a journey to their career path.
No, I think that's very well said, Stephen. Like you need to have that strong resilience mindset. You need to be able to communicate yourself clearly, and then once you have the foundational built up, then you can start to elevate your career by learning coding and the scientific knowledge. No, really. Thank you very much for your time, Stephen.
Thank you so much. It's good to be here.